All right, guys, today we're going to kind of take a step back and we're going to be looking at checking and selecting answers for one-step equations. So what you see in front of you is just kind of a quick warm-up. This is a skill we're going to be incorporating into the checking and selecting answers. So if we were looking at these problems in front of us, these show all the different relationships you can have between a variable, which is your letter, and a term. So this first one is x plus 7, so it shows the relationship of addition, subtraction, a number minus 7, multiplication, 7 times the number, and then division. Again, in algebra, we have this fractional bar to represent your division. So if we were going to evaluate all those different relationships there, if x was, let's give it 21. Let's say x is equal to 21. So if we were going to evaluate all that, we take out the variable or we replace it with a 21. So the first one there, x plus 7, again, I'm going to just write it over there so you can really see that I'm kind of replacing or writing over that x and putting in a 21. So 21 plus 7 is going to give us, it's equal to 28. So again, this computation here on the left is equal to this answer on the right. The next one, x minus 7. So again, if I put in my number 21 and I subtract 7, you're going to find that it is equal to 14. Again, the computation on the left is equal to my answer of 14. The next one here, we have 7 times x, 7 times 21. And be careful because when you are plugging in the 21, you don't want to look at it as 721. Again, remember there's the operation of multiplication in there. And this is going to give us a larger number because we are multiplying. And it's going to be equal to 147. And the last one here is the relationship of division. So again, I substitute or replace my x with my value of 21. 21 divided by 7 is equal to 3. So now kind of taking a step back after we've evaluated all these, we actually turn those expressions into equations. Remember, the key characteristic of equations have an equal side. And again, my computation on the left is the same value, just written differently, than my answer on the right. They are the same thing. So keep that in mind. All right, so why we went over that is because that process is kind of the exact same thing as when you're checking your answer. So if you see here on the left, we have the equation x minus 8 is equal to 24. So this is my original equation here. And I have found the answer to be, I used my opposite operations, I found my answer to be 32. Now, when you go to check your answer, again, you just said my mystery number or my x is equal to 32. And here is my equation. So you could take this answer of 32, and again, we're going to plug it in right over top of my x. Now, again, you could rewrite it. May not want to scribble on over it. But again, my computation on the left should equal my answer on the right. And what you could do is you could grab a calculator, get mine up here for you. Throw that computation in there, 32 minus 8, that is the side that I actually have an operation going on. And I do, in fact, get my answer of 24. So this problem, you would know, if you were checking your work or checking a problem, is correct. Because again, when I substitute that value in for my variable, I get the correct answer of 24. Take a look at the second example here. We have x plus 2 equals negative 10. So here's an addition relationship. Solving through the problem, this person found that x is equal to 8. So again, checking your work, we're saying that the value of x is 8. My mystery number plus 2 gives me the answer of negative 10. If I go back and I, again, substitute that answer in for my variable, we do our calculations. Here's where my operations are. 8 plus 2. So again, you can grab yourself a calculator, plug in your computations, and I get the answer of 10. Now, does that match? This side gave me 10. My answer should be negative 10. So this would be an example of when your answer doesn't match up to what it should be, which means you did the problem incorrectly. So this would be an incorrect answer. And you would know to go back and check over your work. If we kind of look over it quickly here, we did do the opposite. This person did do the opposite operation, correct? Positive 2, minus 2 on both sides. But here's where they fell short. Negative 10 minus 2 gives you not 8, but negative 12. So again, it just kind of clues you in that, hey, you did not get the correct answer. Go back and check your work. All right, here's two more to take a look at. So on the left here, we have 3 times x equals negative 15. Again, this person went through and did their work and found their answer to be a positive 5. So to check it, we go back up to that black original equation, and we have 3 times x, 3 times 5, because that was our answer from our problem. Doing that computation on the left, I should get my answer on the right. So let's check it out. We have 3 times 5, we got a 15. We need a negative 15. So not quite right. Close, but not right. And again, you could go back in your work and check to see where the error was. Now, normally, if it's just a difference of the sign, your answer should probably be negative. Just, you know, some kind of thought to it. But again, you could go back to your work and correct it. So this would be an example where your work is not correct. The answer is not 5. All right, look at the example on the right. So again, my black equation here shows you the relationship of division. X divided some mystery number divided by 2 equals 9. This person did their work and found out their answer to be 18. So if we're going to evaluate it or check our answer, we plug in the 18 for the X. And again, here's my computation, and I would need to hopefully get the answer of 9 in my calculator. So 18 divided by 2, I indeed get 9. So this would be correct. This person did the problem perfect. All right, 2 more here just to hopefully make sure you know what you're talking about when you're checking your answers. Again, it's a good skill to have for multiple reasons. So again, this person went through the black equation, 4x equals 20, 4 times a mystery number equals 20. They did their work and found their answer to be 5. So again, a good practice is to go back and check. So 5 goes in place of my x. That was what we said our answer is. And again, there is a multiplication relationship between the 4 and the x and the 4 and the 5. Here's my computation that I put into my calculator right here, 4 times 5. And again, here's the computation I put in. I need to be getting this answer of 20 in order for it to be solved correctly. And in fact, I did. So this one on the left is also correct. All right, take a look at the one on the right. We have x plus 4, a mystery number plus 4 equals negative 15. So person solving through said, hey, I think my mystery number is 9. So again, you kind of evaluate by plugging in that number for your variable. Here is the side with my computation. 9 plus 4 equals negative 15. Let's check it out. What is 9 plus 4? And we get the answer of 13. So again, if I'm looking at my calculator, you could write it down if you need to. 13 does not equal negative 15. So this person did the problem incorrectly. 9 is not the mystery number. So again, if this was you and you were checking your work, you would know to go back, double check your computations, double check that you did the inverse operation correctly to get that variable by itself. All right, so your assignment, just to kind of touch base with you, looks like this. This is the first part of your assignment. And what I'm looking for is, here's your black equation. Here's the person solving the problem in red. What I want you to do is you're checking your calculator. So if you could rewrite this equation over in this box, and again, instead of an x, I'm going to write my answer, which is 6. That is what goes up there. So 6 minus 4, instead of it being a mystery number minus 4 equals 10, we now are saying, hey, I think it's 6. 6 minus 4 equals 10. When I do this part in my calculator, 6 minus 4 is 2. 2 does not equal 10, so therefore it would be incorrect. Now you can highlight, you can circle, you can bold it. If you're doing it on the computer, just as long as you can kind of indicate whether it's correct or incorrect, I'm completely okay with it. So for the first half of your assignment, the first 5 problems, that's what you're doing. You're rewriting the equation with the answer plugged in for the variable, solving through and telling me whether, hey, it makes a true statement or not a true statement, and then correct or incorrect here at the bottom or on the side. All right, so also kind of looking at this skill, it's very valuable to be able to plug in numbers to see if it makes the equation true. especially if you're given a multiple choice assessment, because it kind of saves you from doing a lot of the work. And again, there's not always one way to solve a problem, and you use whatever skills you have in your toolbox to solve. So here's my equation here, x minus 8 equals 18. So a mystery number minus 8 is going to give us this answer of 18. But here's some options for us that we could try. So first we could try 10. And again, you're kind of taking that 10 and you're plugging it in for the x. The side of my computations is here on the left, so we're going to go ahead and do 10 minus 8, and I get 2. I should get 18. If that's the right answer, I should get 18. It is not the right answer because I got the answer of 2 in my calculator. It does not match up. So right away, you know that that's not correct. All right, so if I tried 26, so again, this is not it. Not it. If I tried 26, again, I'm looking at plugging in that 26 for where my x is. My computation's here on the left. So if I take 26 and I subtract 8, I should be hoping for the number 18. And I do, in fact, get 18. So guess what? That when you get matching answers, when you did the computation on the left and you get the same value as on the right-hand side, making it equal, which is what an equation does, that is your answer. All right, so let's take a look at the next one. We have x plus 10 equals negative 30. So again, rather than solving it straightforward, if you are given options, you can use the evaluation method to figure out which one it is. So here again is my equation. I have a number plus 10 equals negative 30. So let's try the first option of 20. And that again means I'm taking that 20 and I'm replacing my x, writing over it, however you want to think of it, solving my computation here, simplifying it down. So 20 plus 10. And I'm shooting for the answer of negative 30. In my calculator, I get a positive 30. So it's close, but it's not quite. So it's not my answer. So let's get that 20 out of there. It is not it. Okay, look at the second one here. We have a negative 40. So again, I'm replacing my x. We're going to try negative 40. So if we have a negative 40 in there and we add on 10, hopefully we get a negative 30. So let's try it out. So we have a negative 40, and we're going to add on 10. And we do, in fact, get our answer of negative 30. So again, here's another B answer. But once you plug it in, you should get the answer on the end. So you know that you were correct. All right, so we're running out a little bit of time here, but hopefully you understand the, you plug it in for the value and you solve for the answer and make sure that it matches. So for part 2 of your assignment, this is what it looks like, 6 through 10. You've got an equation here and you have you have some options to plug in. So for this first one, you would take the 8, plug it in for your x, 8 plus 7, and see if you get this outcome, this answer of 15. So once you figure it out, you're just going to highlight, bold, however you want to do it on the computer to show me the correct answer. So again, I hope you find this useful, especially as we get into more complex equations, and it's easier to evaluate versus solving it out the traditional way. I think that you'll find that this is very helpful. So good luck. Reach out if you need any help on your assignment.